This video will demonstrate how to implement the map using a binary search tree. Hello, I'm James Helfrich. When I first started using the map, I was really confused with how that could be implemented. Every array I've ever used before used an integer as an index, which is just an offset from the first element in the collection. But a map can use anything for the key. How could that possibly work? This video will demonstrate how we can implement the map using a binary search tree. Okay, the first thing you have to realize about a map is how the client visualizes it. Let's say I have an int float map. So I'm going to say grades of 165 equals 94%. So my key is going to be 165 and my value will be 0.94. And if I say grades of 124 equals 97%, then my key is going to be 124 and my value be 0.97. Notice how that they're sorted. If I say grades equals 235, then this is going to go after 165. And now I have three keys, 124, 165, 235. We sort by keys, not by values. And the values are along for the ride, 0.89 in this case. When I add 213, 213 sorts before 235 and after 165. So I got to move it over. And then, of course, 246 goes on at the end. Now, the question is, how do we implement a map in such a way that I don't have to scoot things over and do too much work? Well, the answer is we're going to use a red-black balanced binary search tree. So let's do exactly the same problem again. So I'm going to say grades 165, and now I have a single node, and this node has a key, 165, and a value, which is 94%. Now, when I say 124, 124 goes to the left of 165. And since this is a red-black tree, it becomes red. When I say 235, 235 goes to the right of 165, and it is also red. Now, notice in each node, there's going to be two components. There's going to be the key, the integer 235, and the value 89% in this case. Now, when I go 213, 213 is to the right of 165 and to the left of 235, but I'm going to have to recolor my red-black tree. So 124 and 235 will become black, and 165 will become red, and then it'll become black again. And then I say 246, it goes to the right. Okay, so the super important thing to notice here is we have a BST, and every node is going to have two different components, the key and the value. And we always sort based on the key, and the value is just along for the ride. All right, now let's take a look at a class diagram for this. I'm going to start with a map, and the map is going to have my usual constructor and destructor, as well as the usual assignment, size, empty, clear, and swap. Okay, not a problem here. I'm also going to have an erase where I erase a key, which means that I have to specify the data type of the key and the value in the map. So we're going to add two template parameters, key and value. Now I'm going to have the square bracket operator, which takes a key and returns a value, and the @ which takes a key and returns a value. No problem there. Now I'm going to have a find, and find is going to return a map iterator. So therefore, I need an iterator class, and this iterator class is going to be nested within map, so we map : iterator, and then begin and end will also return an iterator as well. My member variable is going to be a BST, as we mentioned before, so therefore I need a BST class. Now, the BST is going to be a nested class within map. In other words, the client shouldn't have access to the BST directly, so this be a private nested class. And how many BSTs am I going to have? I'm going to have one by composition. And it's composition because map is going to create and destroy the BST. So there's exactly one. BSTs don't know anything about keys and values. BSTs only know about T's, their template. So somehow I got to turn my key value from map into my T for the BST. And we do this through something called a pair. Now, a pair is a template class with two templates, key and a value, and I have two member variables, a K and a V, or a first and a second, whatever you want to call it. The important thing to note is the data type of K is key, and the data type of V is value. And then a less than and greater than operator, all that only work on the key. The value is just along for the ride. Now, how am I going to turn my map key value into my BSTT? I'm going to do that through association. Association basically means anything that's not composition or aggregation or inheritance or nested. In this case, that is how I'm going to convert my key value into a T. Now my insert is going to take a pair as a parameter and return an iterator. So how does that BST work? Well, I have a head to my BNode and the number of elements. So I need to have a BNode class, and this BNode class is going to be nested within the BST. And how many BNodes am I going to have? Well, I'm going to have as many as different elements there are in my BST, or in other words, however many elements there are in my map. Now notice how it's composition, even though head is going to be a pointer to a BNode. And it's going to be composition because BST is going to create and destroy every node. Now, what's in this BNode? Well, I'm going to have a parent, a left, and a right, and all those are a type BNode. And I'm also going to have my value, which I'm going to get the T from my base class. So which means there's going to be association. And how many are there going to be? There's going to be 0 through 3. 0 in the case when I only have a single node in my BST. I have no parent, I have no left child and right child. 3 when I have a left child, right child, and a parent. But of course, I could have 1 or 2 as well through any combination thereof. Now notice how it's aggregation, it's not composition. In other words, if I destroy one BNode, I don't automatically destroy the parent and the left and right child. I can operate them independently, and that's what aggregation does. Okay, let's go down to that iterator. Now the iterator is going to have a single BST iterator as a member variable, which means I need to have an iterator class, which is nested within BST. My map iterator is going to have exactly one BST iterator. In other words, I'm going to create and destroy my BST iterator when I create and destroy my map. The BST iterator will have a single attribute, P, and it's going to point to a BNode. In other words, it's going to refer to, by aggregation, a BNode. And it's going to have 0 through 1. 0, if this is the null iterator, 1 if it refers to an actual BNode. And notice how it's aggregation, it's not composition, because if I destroy the iterator, I don't destroy the node it points to. You can learn more about the implementation of the map in the implementation section of the map chapter of the C++ data structures textbook.